In this video, we're going to look at some more SUVAT problems involving vertical projection. So let's take an example. A ball is projected vertically upwards with a speed of 21 meters per second from a point A, which is 1.5 meters above the ground. After projection, the ball moves freely under gravity until it reaches the ground. Modeling the ball as a particle, find the greatest height above A reached by the ball. Find the speed of the ball as it reaches the ground, and we also need to work out the time between the instant when the ball is projected from A and the instant when the ball reaches the ground. So in all mechanics questions, it's vital that you draw a diagram so you can visualize what's going on. So let's start off by drawing our diagram. So we have a platform here above the ground. Here's our ball that's projected vertically upwards. Now the arrow is very important. So we know that in the question they say it's being projected with a speed of 21 meters per second. So here's the point of projection A. Now U is 21 meters per second. And we know that it is 1.5 meters above the ground. So one of the things to realize in a problem like this is 1.5 meters below the point of projection. Now we're going to be coming back to that during this problem. So for part A, to work out the greatest height, we're going to do SUVAT. So for part A, taking upwards as positive, we're going to do a SUVAT here. Now that means A will be minus G, U is 21, it goes to maximum height, so V is 0, and we want to find S. So we're going to use V squared is U squared plus 2AS. So we can say 0 squared is 21 squared minus 2GS. So 2GS equals 21 squared. So S is 21 squared over 2G. We can work that out on our calculator. 21 squared over 19.6, which is 22.5 meters. That's the greatest height above A reached by the ball. Then for part B says to find the speed of the ball as it reaches the ground. So when it reaches the ground, what we need to realize is we're still going to take upwards as positive. Still going to do a SUVAT. Now we're taking upwards as positive because the question states that the ball was vertically projected upwards. So U is 21, A is minus G. Now we want to find the speed as it hits the ground. Now don't forget that the displacement, so that's minus 1.5. So S must be minus 1.5. So now we can use V squared is equal to U squared plus 2AS. So we can say V squared is 21 squared minus 2 times G times minus 1.5. That gives me V squared is 21 squared plus 3G. We can work that out on our calculator. So we're going to get 21 squared plus 3 times 9.8, which gives me 470.4. We're going to square root the answer. So we're going to round the answer to 3 significant figures. So I get 21.7 meters per second. That's been rounded to correct 3 significant figures. And don't forget, part C says find the time between the instant when the ball is projected from A and the instant when the ball reaches the ground. So don't forget again, it's 1.5 meters below the point of projection. So when we do our SUVAT, we've got to be careful. So we're going to do a SUVAT again. taken upwards is positive. So U is 21, A is minus G, T I'm just going to call capital T, that's what they've done, and don't forget S is minus 1.5. So we're going to do S equals UT plus a half AT squared. So that gives me minus 1.5 equals 21T minus 4.9T squared. So bring everything on one side, I'm going to get 4.9T squared minus 21T minus 1.5 equals to 0. Now we can solve that on our calculator. So press alpha minus, which is polynomial. We could just type the coefficients in, 4.9 minus 21 and minus 1.5. So the first solution will give me 4.36. So I'm going to get T equals to 4.36 seconds, or T equals minus 0.07, which is invalid. So the solution we want is T equals seconds. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So this question says a ball is thrown vertically upwards with a speed u meters per second from a point P at a height h meters above the ground. The ball hits the ground 0.75 seconds later. The speed of the ball immediately before it hits the ground is 6.45 meters per second. The ball is modeled as a particle. Show that u equals 0.9. Find the height above P to which the ball rises before it starts to fall to the ground again. And C, find the value of h. So as always in any mechanics questions, we would have to draw a diagram. So let's start off by drawing a diagram here. So we've got our platform, that's the ground, and it's h meters above the ground. Here's our particle. It's projected upwards at the speed of u meters per second. And also they tell us in the question that it hits the ground 0.75 seconds later. So it hits the ground with a velocity of 6.45 meters per second, and the time that happens is 0.75 seconds. Now we're going to work out what u is, so let's do a SUVAT for that. So it's going upwards, it's minus g. U call u is u. Now we know that the final velocity, the final velocity is going down, so it must be minus 6.45 because we're taking upwards as positive. Then the time is 0.75. So we can use V equals to U plus AT. That's our SUVAT equation. So minus 6.45 is equal to U minus 0.75 G. So we can say U is 0.75 G minus 6.45, and that will give me 0.9 meters per second as required. Then for part B, we're going to find the maximum height. So again, we're going to do that by SUVAT. So it's minus g. Now we know that u we worked out is 0.9. Trying to work out what the height is. Its maximum height, so v must be 0. So v squared is u squared plus 2as. So we can say 0 squared is 0.9 squared minus 2gs. So 2gs equals 0.9 squared. So we can say s is 0.9 squared over 19.6. What is that on our calculator? So we get 0.9 squared divided by 19.6. And that gives me 0.0413 meters to 3 significant figures. Then to find the value of h, don't forget h is below the point of projection. So when we do our SUVAT equation for part C, taking upwards is positive. So A is minus G. Now V is minus 6.45 because it's the opposite direction of what we've taken originally. It's taken upwards. U is 0.9. And don't forget, because h is below the point of projection, it must be minus h. So now we can substitute this into our SUVAT equation. So we can say v squared is equal to u squared plus 2as. So we can now say that minus 6.45 all squared is equal to 0.9 squared. And then we can say plus 2 times minus g times minus h. Don't forget, two minuses times together make a plus, so we get minus 6.45 all squared equals 0.9 squared plus 2gh. So we can say 2gh equals to minus 6.45 all squared minus 0.9 squared. So 2gh is going to be equal to 40.7925. We're going to divide it by 2g. And that will give me 2.08 meters. Correct to 3 significant figures.